Thanks everybody for joining for this session today. We would be focusing on GraphRag. And as part of this series, I've got five topics. We have covered the basic RAG in the last session. Today, we'll take this course to the next level. We will talk about GraphRag, and there are three more sessions which are there in the series. As last time, we'll discuss concepts, technologies with some examples. I want to keep these sessions at high level so that everybody can understand, not just people like me. So the idea is basically to keep these sessions at a conceptual level. The purpose is to introduce a concept. I do my preparation, I create demos so that I can answer your question, but feel free to go to the next level with me if you want. Just ping me, we can set up more sessions going into the depth of it, how we code and implement. I use Azure platform because is my kind of background, but most of the content that I'm discussing are using open source technology, so they are agnostic to model providers. There are a number of companies who are having these foundation models. Also, the platform providers like AWS, Azure, GCP, or you can actually implement locally, which is the next session we're going to have next week. Join my LinkedIn group if you want to. The idea is to really discuss, collaborate. I do post things which are relevant, some curated contents in terms of market and technical insight. I have also done two more series before that, and you can always go through these sessions. The links are provided in the invite. So let's start and see what are the limitations of baseline RAG. So we've covered baseline RAG. RAG is nothing but retrieval augmented generation, or the way I put it, generation augmented by retrieval. So what you do, instead of relying on the data on which these language models are trained, while you are prompting the model for some information or asking question, you provide some context after retrieving it from knowledge sources. Could be a database, could be a SharePoint, any form of data format, and then you provide that to get the more accurate and more grounded response. And it is also very useful if you have data which is kind of live data from CRM system, order management, and all that. But sometimes it has been observed that the baseline RAG is struggling to connect the dots. It is basically you have provided a context, but the data is dispersed across your documents on which you are doing the retrieval. Or sometimes you have data present in all part of the document, and that would lead to a retrieval of a big number of chunks, which will be challenged due to the context windows limitations of the Gen AI models. So how do you solve it? You use GraphRag, and let's see what is basically a GraphRag. So GraphRag is nothing but RAG supported with graph databases. Very simple. So the problem with unstructured data, which is the data source for your retrieval, is due to the complexity because you have a variety of formats, structured, semi-structured, unstructured, which is a challenge for LLM process. And what you do basically, you convert that unstructured in a structured format. How do you do it? So if you look at this graphics, so I've got a text which is John is 30, 2 years old and works for IBM, and Ray is his friend. So that's basically, it has a lot of information, and you can convert into a graph structured format, which is you have these three entities, John, IBM, and Ray, and these entities are connected through relationships like works for and has friends. So if you look at this structure, it kind of provides the same information which is obtained from the unstructured text. And we'll go deeper into these nodes and relationship. Now, interestingly, I recently came to know the biggest search engine, which is Google, which started with a simple full text search, moved to a page rank, which is based on the graph database, and then they convert into more advanced form of knowledge graph. That is currently the model. And then now they're looking at incorporating language models to provide a richer experience. This was an interesting find. Now, before we dive into graph database, there are some popular graph databases, Neo4j and all the other ones. For this demo, I'm going to be using Neo4j. That's very easily available. You can download and run it locally without worrying about the license. So let's look at what is a graph database. So graph database is nothing but a data structure which consists of nodes, which are nothing but discrete objects or entities, and they can connect with other entities through relationships. It is very similar to the entity relation diagram that we have been building for relational databases. And in ERD, you have entities and the relationships, and both entities and relationship can have attributes. They are called properties here. So basically, you have a node which represents an entity, and then you have a relationship in the form of arrow. Unlike ERD, these relationships are unidirectional. That's the important point. Let's take an example, and I'll show it to you. This for your information. There's a movie database which Neo4j provides as a simple graph database for you to work on. So you have a database of movies, you have actors. So a node can have multiple entities represented with person, actor, and that node connects to another entity called movie, and the relationship is person or actor acted in a movie. That's a relationship. And similarly, another entity called director or person here is also connected to a movie, but the relationship is of a different type. So the person has directed the movie in that case. And how do you create the graph? Look at the syntax, don't worry. There is a language called Cypher, which is similar to SQL, structured query language, and with a slightly different syntax, but that's how you create entities. But we'll see how easily we can use GenAI to make it very easy step. So like I discussed, the nodes have labels. So person, actors, these are the labels for the node, and they can have properties. Properties are very similar to the columns you have in relational databases. Now you need to have these attributes to make this entity meaningful. So for example, here, the actor entity has name and say the year of birth. Very similar in graph theory, the nodes are also referred as vertices and points. Let's move on to the next part, which is relationship. So relationship, as I explained, describes how the connection between entities are made. So you have a source node and a target node because the relationship is unidirectional, and it basically also defines a type. Okay, that's how. So as you've seen, we had an actor in a movie. Actor acted in a movie. The relationship is acted in. Very simple. And you can look at the syntax. I don't want to take it to a technical level, but that's how it works. And then you have properties, which are the attributes that defines entities and relationship. They are nothing but name value pairs. Like you have a table, so entity is like a table, and properties are nothing but the columns of the table, because you would also be storing a lot of characteristics of these entities in the relationship, and they are done through the properties. For example, here at the bottom you see there are different properties keys, and we'll see all that in the demo. Now once you have this structure, graph structure, you basically have traversals and paths. So traversal is like how do you query a graph to find some answers, and traversal allows you to move from an entity to another entity via the relationship. For example, to find out which movies Tom Hanks acted in according to the tiny example database, the traversal would start from the Tom Hanks node, follows an acted in relationship, which is connected to the node, and then ends up with the movie node, which is Forrest Gump. And that is basically how uh, the traversal is happening, and is very similar to the join. So when you perform a join in a SQL query, you have one table, another table, and you perform join through some referential integrities. Kind of very similar. So there's nothing new. And then you have indexes and constraints, which are basically how you increase the performance. These indexes are very similar to relational database indexes. And constraints are again very similar, where you define what data types and what values it can have, and that gives you a better control on your data attributes. Like I mentioned, how you basically write a cipher command, and we'll write it, then it will become very clear. And let's look at that. And that's pretty much about graph database. So what I have here, Neo4j, which is the database I'm using, and I have this movie database. So this is the interface like an SQL prompt you had in SQL. And what you want to do, you basically want to query your database. You want to pull out all the records. The query would be like this. Don't worry about the syntax. And what you see here is that graph database. Okay, this is too big. Let's restrict it to something smaller so that we can get a feeling of. So here, the query was search for a name, search for a node with the name equal to Tom Hanks, like a where clause, and return that. And this is where you get this attribute. But is this good enough? No, we want to really see the relationship this entity has and how it looks like. Now, if you see here, you have these entities which are colored as orange. This are basically the related entities from a relation perspective. So if you see here, you have Tom Hanks worked on or acted in these movies. Now we can traverse. Let's take an example. We want to explore more about this movie and what are the related entities for this movie. So you can see there is another entity called Philip Seymour Hoff and Julia Roberts, who also acted in this movie called Charlie Wilson's War. And Tom Hanks basically was used to traverse the database. Now, this is very simple. And if you don't want to learn the cipher syntax, you can actually explore by choosing, let's say, for example, we are interested all the directors and their relationship with the movies, or all the writers who have basically worked, and then you can actually. So, what this represents is kind of entities which exist in the database. Some of the entities would have a relationship with other entities. And what is this structure called? This is nothing but a subgraph. So in the graph database, you will have multiple subgraphs. Like we have multiple tables in a relation database, and some of the tables have a relation with the other table. And that's basically is the graph database. But we are not really here to go more deeper into the graph database. This is just to set the context. Now, what we are interested in is the graph RAG. As we've seen, the baseline RAG has some challenges, especially based on the kind of data you have. I'll give you an example. So if I have a data where there are entities and there are a lot of relationship, which is spread across the document. Now, if you remember, last session we said that these documents are chunked so that based on the user questions, a subset of the entire document, which is nothing but some chunks which are relevant, are obtained. Now, what if your information that you're trying to retrieve is spread across all the chunks? And because of that, probably you will have a limitation because of the context window size. So what we do in such cases, we implement, sometimes we have only a graph RAG, or sometimes we have a combination of an index vector index based graph along with graph RAG. What's the benefit? You get a higher accuracy, it is easier to develop, and the most important thing is explainability, and I'll talk about it. So let's just do a small comparison between an indexed vector index based vector database and a graph database. So you see, from a representation perspective, a graph database is more visual, and you can actually see and make sense, whereas an index, if you see on the right, has got embedding, which is not really human understandable, because these are the semantic representation of the same data in a multi-dimensional numerical form. You perform similarity search or calculation based on two different algorithms. What we have seen in the last session, we use cosine similarity. While you're searching or traversing, you have this traversal through the graph exploration, whereas for vector databases, you have ANN, approximate nearest neighbor, to retrieve information. From a governance perspective, if you see on the right hand side, one can actually look at, when I say governance, essentially I'm getting a response and I want to know why I'm getting what I'm getting. So you can actually go back to the source. Since the data in a graph is represented as entities with relationship, you can actually verify, and it is very transparent, unlike a vector database which is opaque and implicit. Again, comparing vector database to the graph database, if you see on the top what we have discussed in the last session. So you have a document which is chunked after indexing stored in a vector database. When somebody asks a question, the embedding of the question is used to retrieve data from the vector database, and then a subset of the data is sent to the model to generate the response. In case of a graph RAG, the same document would be used to generate entities and relationship in the form of a graph structure, and then the question would be used to retrieve the context in the form of a subgraph, and that would be supplied to the LLM for the final response. We are talking retrieval, here. Generation is going to be common. So that is essentially a difference. You can use RDBMS also, but there are benefits if you use graph database. Now, we have understood what is a graph database. We have done the comparison. We know now there is a additional value you get when you use graph database. Now, do we need to get into, coding aspect of Cypher language to populate the database or retrieve? The answer is no. And that's where we've used LLM. Now, if you refer to the characteristic of language models, they support code generation. Now, you can actually use LLM to generate Cypher queries for both populating the database as well as retrieving the information as part of the retrieval path of RAG, and then the result is then can be passed on to the language model. So you're using language model for graph RAG both for generating the Cypher code, which is nothing but some syntax, and then after retrieving it from the graph database, you use language model to create a response based on the grounded data. So the code is very simple, and I'll just show you. But before that, I have to. So I've created a sample database, which was basically that I've used in the last demo as well, just to maintain the context. Okay, where did I go? Yeah, it's just the data, so I know what kind of response I should be getting, and I can validate. That's basically the data I'm using. Let me just load the database. So I've got a database which I've created. So I have to launch this database. Probably it'll take some time. And what I've done in the beginning, I've created this database as an empty database, and then I've used this code, which is just few lines, to populate this data into the graph database. And I'll show you how the structure would look like. So I've not written much of the code. So there is a library which is available in Python. It's very simple. I've got a document, which is the core data. I use LLM transformer. That is what I was showing here. This 4-line code, and that basically converts my data into the graph database Cypher code, and it executes it. Okay, so let me just show you. A bit struggling with my Windows. Okay, so this data is, it is still starting. Somehow it is slow today, but that's fine. Hopefully it'll start. And once it starts, that's fine. I've got a video captured. just to show you, because I expect password has changed. Good. So let me just pull out. Hopefully I remember the password. Oh my God. This happens all the time. Let me see if this works now. But otherwise, okay, so it is running. And go to the browser. Browser is like an interface that allows you to query the database. This is not used, it's like a SQL Studio. So I've got this database running. This is an IBM database, and I've got that same information. Let's look at the structure. I've got one project here. I can identify the related entities, and then let's say, what is this entity? Santanu, Subrata, Sean. Oh, this is Tarun. Good. And then I can find more about the entity Tarun. Okay. So where is that entity? Tony. Okay. So if you see, this is the entity. It talks about I'm an AI architect, an integration architect, Azure Cloud Architect. So I can actually look at it. Okay. So that's how. And how did I create this database? Just with this 4 lines of code. So I will not be able to run it, but I will definitely show you the retrieval path. So you basically populate the data once and then you retrieve it. So this is a library called LLM Graph Transformer, which is available as a. Now, how do you query that? Because you would be populating it once and then you'll be querying it all the time. Again, couple of lines of code. I'll show you actually. So this is the retrieval. If you forget about this, this is nothing but a chat interface. But essentially, again, just 3 lines of data Python code. So I'm instantiating a graph database, which is Neo4j. Then I'm creating an instance of language model. And then I create a chain, if you're familiar with LangChain. So this is a graph chain. It is a built-in library, open source library, and that's it. And then I start querying, and let's do that. Okay. Let's ask some questions which are difficult for the baseline graph to answer, and I'll explain what do I mean by that. Now, I'm purposely asking questions which are tricky, which have failed in the baseline graph. So my question is, if you remember, who this data, and I'll explain, who is the project manager of the project where Subruto is working. So I've got Subruto working in a project, and there is a project manager of that project. So I'm not asking a direct question. Now, if you try to run this kind of retrieval, so remember the difference between base RAG and graph RAG is purely the difference in the retrieval. Once you retrieve the information provided as a context to language model, that path is common. Now let's run. Now if you see, it has generated this cipher. I don't have to remember, but if you go a little bit deeper, you can actually make out you're searching for a person with the name Subruto, and then identifying the project. This is the direction it has taken, and then you are trying to figure out a manager of that project and then returning that manager. And the answer was Gerard. Okay. And that context was provided to the language model, and then it has generated the answers. Let's ask another tricky question which a baseline RAG could not correctly and accurately respond. So I'll explain what I'm doing. So I've got people working in cities like Kolkata, Sydney, and then these cities are based in a country, so Australia and India. Now, what I'm trying to ask, not about the cities, I'm trying to have a query where it searches for integration architects, identifies the cities, and then identify the countries of that city. Okay, let's see. Now, if you see, this kind of querying of data or retrieval of data is not possible. Okay, so I'm indirectly asking about the country, but the data is not. So what it has done, it has basically, while creating that graph structure, it has created the relationship, and then it is able to retrieve that information that is passed on to the language model to get an answer. Another tricky question, just trying to, I'm not just trying to simply ask who is Tarun, because that is possible in a base like RAG, correct, and it can correctly respond for such simple thing. Now let me just see if this works sometimes. So what I'm trying to do here is, what is the name of the manager of the integration architect who does not live in Kolkata? So I've got a lot of integration architects, and now you can understand I purposely created this document so that I can be confident. So the number of architects. Now I don't want the integration architect who lives in Kolkata. So I'm saying all the integration architects who are not living in Kolkata, it should be able to identify that. And let's see if it works. Oh, sometimes, let's see, funny. Now, last time it didn't give maybe the language model could not create a query correctly, and that's why nothing was retrieved. It happens. Like I said, language models are not deterministic, but if you try it once, so what I'm trying to ask is very indirect. I'm looking for the manager of a person called Tarun who lives in Sydney, but I'm not really going through that path. I'm saying find out the integration architect who does not live in Kolkata, who lives in some other place, which is Sydney in this database, and find the manager of that. So I've got the correct answer. So that is the kind of cases where you would find GraphRag really doing a good job. Now let's go back. That was retrieval code. And sometimes you would like to have a combination of both vector databases as well as graph databases. So this is an example which I picked up from Neo4j site. And what basically end users questions, you basically use cipher generation, natural language to cipher generation, so that you can query the graph database. Similarly, your natural language question is used to retrieve data from a vector database, and that both graph database and vector database have been created with some data source. The path for creating a vector database is through chunking and then embedding, whereas the path for creating the graph database is through entity and relationship extractor. And then the result of it, you would feed to another model to generate an answer. And you can actually choose to rank the response based on the relevance. So, when you retrieve a lot of data, a lot of chunks or a lot of subgraphs, you can actually rank them so that you take the top 5 because the language models have limitation, or it will be very costly to provide a larger context if the language model supports a longer context, but you still like to optimize the cost by just putting the top relevant chunks of information to get their answer. So that's pretty much is about the graph RAG.